All right. So one person. Hello, Jadarian. Is that right?
How you doing?
All right, all right. Thought some other people would be on, but like I said, I went on the. I mean, I opened up this session because some people had was having issues with the visual and the assignment and whatnot. Yeah. I guess I give them another minute. If not, we'll start. So this is some other people had joined. All right, so Mr. Jadarian, how you doing? Again,
I'm doing good.
all right. So what kind of questions you may have, or concerns or whatnot? Try to answer them.
All right. The one thing I try to make sure is like when we're doing the programming assignments, there's like all information that we need is like in the videos on YouTube that we just watch.
I won't say all, but most, but also in my notes. If you look, you do have I can say the book, or you got the book. I got a PDF of a lower edition which you could use. But if you went to my website, well, let me share my screen.
All right.
All right. But if you went to my website, we just type it in, get this out of the way. So when you go here on this screen and you type and you go to this site, you can see chapter 7, arrays. And I do have some notes broken down into small bits, but it's still notes from the chapter. You understand?
Yes, sir.
So you can use this information along with the book, but this should, and then like I said, I have also some sample programs that you can either type or look at or whatever that can also assist you in writing your code. All right.
Okay.
So here, like I say, this was the first chapter. You have to worry about this example. I don't think it's have a link. I think I took the link out. Oh no, I left it there. Oh, I left it there. But that's not an assignment. That's just was practice. Where you get to understand how to do data files, which hopefully you learn some about how to write and read from data files in 193. But I think I have a video in the how-to on how you create the video, how to create the data files. And I may have it, I'm not sure. I may have it in announcements, but I know the video should have it. But like I said, if you scroll through, it gives you information on arrays, all right? So, but like I said, it's not all of the information from the book. It just I picked out highlighted parts so that you could see and look at and get an understanding. If you want more understanding, you could go to the book and view the book content. All right. So it talks about the arrays and all the information. Now, and like I said, when the programs, I would say, is created based upon what these notes give you, in a sense. Not totally, but like say to get started and do that, because you still got to come up with the algorithm and put the program together. But for the most part, the meaty part of it, it's in here. Like say even writing the program. All right, passing a array as a function. See, passing the entire array. This program shows you how you can declare using a function where you have the array in the main function, which is called, in this one, it's called numbers. And it's a array size of 8. But the array is declared and initialized here, but what? You say show value. Show value is being called, and it's passing numbers into an array called nums in show value. So it shows you how you can create or pass an entire array rather than passing each individual value. So you pass when you call this function here show values and you pass numbers, you also pass the size of the array. What happens here? All of the content of numbers is stored into nums. So now in this program, I could do nums of 1, 0, nums of 1, nums of 2, and it's acting as if you're doing numbers of 0, numbers of 1, numbers of 2, etc. So like I said, the notes give you insight, give you information as to how to do the programs or whatnot. Another question. You was able to download visual? Mr. What the name? They got other people on too. Mr. Jadarian, did I answer your question?
Yes, sir.
Okay. And like I said, then you got some of the other, and then the assignments. Okay. The assignment here. All right. These assignments tied to to Canvas. All right. So like I said, when you look at this, again, let me go to Canvas. If I go to Canvas and I go to modules. Now this is how I would tell you to do your or follow through for the class. When you log into Canvas, go to modules. You can go to the calendar for the due dates, but I would suggest, but you don't have to, go through modules. Modules will show you a broken down version of what all I want you to do. So here is all of the pretty much some of the bonus and other information that I want you to know. Now, if you look here, summer internships. Whenever I get a summer internship that somebody's posting or sending to the school, I'll put it under here. If it's research opportunities, I'll put it under here. And once I put it, I'll click on the link to say notify, each individual. Job, if it's a job, I'll post that. I'll post that job opportunity. So that here's where you can, when you go into Canvas, go to modules, where you'd see those opportunities. Here are some of the previous lectures. So like my previous, when I had face-to-face, all right, summertime, we normally don't do the face-to-face, but you can go and look at my face-to-face lectures as if you was in the class at that time. Now they're not really labeled as per se chapter 1, chapter 7, chapter 8, but you can kind of fast forward through it or look through it to see the content to get where you need to get. Oh, the additional notes that just takes you back to my website. Well, no, it has yeah, my website, I think. So it's like what is the companion notes? There's notes from the publisher that you can look at and review. All right, so they want me to download it, but I don't want to download it. All right, so now, but if you look, week 1, so this is what you should have started and done already. Started reading the chapter. Well, this is just a quiz, because what happens is you read the chapter, then I give you a bonus saying, oh, I've read the chapter. But it's like that's under the bonus section, 5-point bonus. Point going to your bonus point. Student contract. That says that I've read the syllabus, I agree to the syllabus, I'll abide by it. And then I have these other links here where you can, like I say, some people were creating and compiling a C++ program, and I think it's in visual. Some people, right, it's in visual, and I have a visual, and it's YouTube videos. It's this is 2010, 17, 19, and 22. So the different versions of visual. All right, it'll show you. If I go back, so this would be like the guide I would follow, but you don't have to. You could go to the due date, but the due date normally just show it to you when it's due, and you don't want to wait to see something that's supposed to be due on the due date when it's a program or something that just gonna take too long, and you might not be able to complete it. If you notice, this was a bonus program, all right? Program I asked you to do using arrays. I think it's arrays, which it is, the first chapter. To do array was bonus. Just write a simple program to read in the information, write out the information. But I think using functions, okay? I'm not gonna click on it. But it also says you should include a header file. I'll go over that, but I'll entertain questions too, but I'll show you how that works also. So you can see me go through doing it, all right? And some of the do's and don'ts, or maybe questions you may have. And look, well, somebody had that question too. They were saying like, well, Mrs. Investor, do I need to turn in all of the files that's in my project folder? No. Only files that I would need from your project folder is your .cpp file and your .h file for this assignment. But when we do data files, if it's an input file, normally I would do .txt or .dat or whatever extension I give you or you create. If I don't give you a specified one, but normally I put .dat or txt because I specified so that you upload the proper one. So an input file and maybe an output file. All right, so those are some of the type files that you would be uploading. And this restricts you from uploading any other file with any other type extension. So like if you try to load a file called program.docx or doc, it will restrict you and tell you it's the wrong type because it didn't have a .cpp extension or it didn't have a .h extension. The .h extension would be for the header file. .cpp would be for your source file. All right, and I'll show you that in a little while. Let's go back and still here. Now, you have a quiz for each chapter. You have a quiz. So, like I said, you got the quiz, a little bonus quiz to say I've read the chapter. But you have a quiz associated with quizzes, and that's 15% of your grade. That for every chapter you're gonna have that quiz. The quiz is just about 5 or 10 questions pulled from the actual test questions. All right. So it's questions you'll probably see again, because when you take the test, those same quiz questions could be in there. Then if you notice, for every program, now this was bonus, so I didn't worry about it, or I don't be worried about it. But for every program that you have to write, the logic and whatever, I also ask you to submit documentation that goes along with that program. Now, some students, they don't feel that this is an important part of programming, but it really is, in that the more documentation you have, excuse me, class, I didn't even turn my phone. Right. The more documentation you have with the program, the more documentation you have with the program, the better it is for somebody to pick it up and go with the program. And what I mean by that is, like, if you have a program that you've written and it's like 1,000 lines of code and there's no documentation, but all of a sudden that company assigns another person, or you, like maybe 10 weeks later, and you've written 50 to 100 programs since then, and now you have to go back and modify that particular program, it will be very hard for you to remember all what was going on, why you used that variable name, what this loop was doing, why you calling this function. So if you had documentation, you're able to go to that documentation and say, oh, this function did X, Y, Z. Oh, this variable in this function is used for this. Oh, this variable is used for whatever. So even though it might not give you all that you need to understand what was going on, it gives you a better jump start to modify the program. And you'll start seeing this in the real world once you start writing code for companies, right? Because many times companies have, just like when you when people write apps, they write apps, then what? They have to update them, all right? But sometimes the person that updating them might not be the same person. They may have gone on to another job or whatever. So another person coming in to modify that app, depending on their knowledge and depending on what's needing to be done, they need to get a little jump start so it won't take so long for them to complete it. So in this documentation, for every assignment, documentation assignment that I give you, I have this link. Now, I tell the students, this is almost like gimme points, because really I'm asking you to have a cover page with this information on it. Have a statement of the problem. What is the statement of the problem? The statement of the problem is all of the instructions that I give you to do the assignment. Program 1, write a program that will X, Y, Z, whatever. If I give you examples, if I give you function names to use, if I give you data file names to use, if I give you a sample of the output, a sample of the input, all that goes with the statement of the problem, okay? All that information is a part of the statement of the problem. So let's look at, I'll go back out and I'll go to program 1. So let's look at assignment 1, program 1, assignment 1. When we look at this, all right? So this here is just sample information on the header. This is not really the program itself. But if we click on the assignment, all right, here is your assignment. But if you scroll down, also it gives you what? An example of how the output looks. So what happens is when you put all this in your documentation and later on another person comes to modify that program and they looking at this, they see, okay, this was the instructions. This is what they were supposed to do or what this program is doing. And this is how the output should look. So they have all that information there so they don't have to try to run it or figure out what's going on, all right? So all of this information would be the statement of the problem. So I would want you to take this and put in the document in a Word document, cover page, statement of the problem. And then the next thing would be, all right, let's go back out. Let's go back to problem 1 documentation. And the next thing would be is the source code. All right, if it ever come up. Come up. All right, so the next thing would be the source code, all right? The source file, the contents of the source file. You're gonna give me the name of it. It could be called prog1.cpp, all right? And then all its contents, all of the command, the statements that's in that file, all right? So that's the next section of that document. And each one of these bulleted or numbered items, I want you to start them each on a new page. That's important. I'll take points off. I want to make sure you, if my, when I cover page, I want that to be that 1 page. Statement of the problem might be 4 pages. So what? And it might, or 3.5 pages. So I'll start on page 2 and end on page 4.5. But I don't want the source code to start on the next half of that 4th page. I want that new page, and then your source code name at the top, and then the name of the and the contents of the source code. All right. After your source code, which is the CPP file, you execute the program, and now I want you to screenshot. All right. Now, important. The source code, I want it in text form. So you're gonna copy it and paste it into the Word document. Now you say, well, Mr. Sylvester, I could just screenshot it and give it to you. Well, that's true, but sometimes, just sometimes, students screenshot the source code, and then sometimes it's so small that I can't, when I stretch it to view what their source code is, it become blurry. Because I have to stretch it so large, you screenshot it. Your screenshot was so small that once I enlarge it, it becomes blurry because it's an image. But if you give me the text of it, like this is text. So if I enlarge my screen, see my text enlarged also. You understand? So it's not really getting distorted. But if that was an image would get distorted as large as I created. But now the screenshot has to be an image. So you screenshot your output, and then you're gonna put that on a new page. So whatever output you get, that's on a new page. All right. Now, sometimes we're gonna have a data file. Your data file output is not the output of the program. Your output file would be the output file content, because you could have a screenshot. You could have output, and then you can have your data file where the output would be enter a number to search for. And then when you enter that number in the output file, it'll say, oh, I found that number. This is the number. Then it'll say, oh, do you want to exit this program? But then in the output, program ended. You understand? So there's 2 different things. The screenshot of the output on the screen is different from the output of a data file, because I do actually give me the data file content. So here we go. After the screenshot, however many pages, on a new page, the name and content of the header file. And everybody should give me that information, because the header file, your name, what is program name, the course name, number, my name, your name, and due date, right? So, and that should be in that other should be in that header file. So that header file information, you should have that and give me the name of the header file and the content. Then on a new page, if applicable, because all programs may not have a input file. All programs may not have an output file, or sometimes it might be more than one input file or more than one output file. But the name of the input file and then its contents. Now, with the input file, you would just select it and copy it and paste it as text so I can see it. Same thing with the output file, you select it, copy it, and paste it as text. All right. Now, this last part of this document, many people get confused or they just don't do it at all, figure it's not important. But you need to do this. This is pretty much really the meat of your project. And it says the data dictionary. The data dictionary, all right, I want all user-defined variables. So any variable that you create, whether it's a file object, whether it's a function, whether it's an array, which is a variable, any other variables, I want them mentioned in this data dictionary. But I want them grouped by the function that they appear in. Now, example, you might have the variable count that controls a loop appearing in the main function, appearing in the input data function, appearing in the print function. It has to be listed each time in each function, telling what it is and what its purpose is. All right. So what you do, go to each function, list all of the user-defined variables, give their data types, and then the purpose that they're used for in the program. And I think I'll give an example. I'll show you. I think I did it in the documentation. So it says each listed item 1 through 8 should begin on a new page. For example, it should be your. Okay, your source code may be 3 pages long, but the screenshot of the output should still begin on a new page. All right. So wherever that information stops on that third 3.5, 4.5 pages, that next information, the screenshot should be start on a page by itself. So let me edit this real quick. That should say your and then we'll continue. All right. All right. Okay. So I'll just save this. Now, so that's the documentation, right? Now let's look at what this is a sample documentation, and like I said, you can download this and use this as a format. Put the program name, course name, instructor name, your name, date. Now it don't have to be this. You could create. You could do whatever. Make the cover page however you want. 1 page. Then what? Statement of the problem, right? And then what? Put all of the information that goes along with statement of the problem. So what I did, because sometimes in using Word, if you don't put a hard return at the end of each section, it will allow that information to start on the same page. So I've formatted this document to where there's a hard return at the end of this page, so that whatever you type within it, this gonna always be on the new page. So source code or the source file, give the name of it, and then underneath, give all the instructions that was given, however number page it take. Screenshot of your output. So you're gonna do what? You can use Snippet, which is a utility in Windows if you're using a Windows system. If you have an older Windows computer, the keyboard, you could do Control Print Screen, because it does a copy and then you paste it. All right, you can paste it back into the document. All right, so all I want is a screenshot. Sometimes you might have to have more pages. So you screenshot the first part, scroll down and screenshot the next part. All right, header file. That header file is standard. I'll show you that in a little while. That should be the same pretty much for all programs except for the due date and the name of the program. All right. And then input file, if you have an input file where you read in a name and a number, whatever that input file name is, and then the contents of that input file, copy it and paste it in there. Output file, when you run your program, it sends the information to the output file, you give your name, and then you're gonna actually copy and paste the contents of the output file. And then the data dictionary. So if you look here, so what I want, the function, variable name, it could be the object name, whatever that name is, but do it by function. So now, sometimes you have global variables, just put up here, have all your global variables, then you start with your main function. Okay, the main is what? Void. When I just example, it could have been int where you return 0. All right, but I use example of it being void. All right, and it's the driver function for my project or my program. Then I have a variable called x that's within the main, and it's of integer, and it's a counter used for loop to input data. So you understand the data, the variable name, the data type, and how it's used in the program. Now, when you've listed all the variables in the main function, then you can either put an extra space or whatever, then you give the next function that you using in your program. They don't have to be in order. It doesn't matter what function you put first, but I want the data to be, the variable names to be grouped by the function. So you can have what? Get data. Okay. And if that function is void, you would put void. Or if it was int, you put int. And it would be the function to retrieve data from input file, you know, and then you would list all of the variables that's a part that's used within that function. Okay, so that's my data dictionary, and this is a grade just like your assignment. So, like I said, you get this right. At least you got half of the points you need. You know, like if you add them together, you know, you got half of the points, and then you do the assignment, then, you know, it's a total point. But this is counted as a grade, 25 points. But like say you don't have your data dictionary, I'm taking 5. You don't have this, taking 5, taking 5, taking 5. You know, so that's how I'll do it. I'll delete points for not having, but then if you have, then I'll say, okay, well, this the statement of problem incomplete. Like you may have just put in the instructions, and you didn't put the specifications for the functions and the output. So I'll say, okay, incomplete -2 or -3, depending on how much you put. All right. Screenshot of output does not start on a new page, -1. You know, so I'll deduct points, you know, for you not having information in the document. All right. So that's how that is graded. And for every assignment, you're gonna have to submit that along with the program. All right. So every program. Now, let me go back out. And like I said, I'd work for modules, but like I said, it's up to you. I don't know, so it's up to you how you want to check to see, you know, if something due or whatever. But I would go through the week to week thing. All right. So all this, you have one assignment, 2 assignments. All right. Now, what else on? And then the next week, which is week coming up, you got the test. All right. So that the test in the following week is a test from the previous chapter. So, and then you'll see that in each week. All right. The next week, what test 2 is given after you do all the information, all the work for chapter 2 when you took test 1 in the week that you took test 1. Same thing, test 3 is taken after you do all the work for test for assignment 2. All right. I mean for that chapter after you take a test 2. All right. But you got all week to take test 2. But I would not wait or try to wait the whole week to take it. All right, or the end of the week to take it, because things do happen. All right. But like I said, you got that time. Now, another thing with my test, you have 2 opportunities to take the test. So you could take the test, like I say, on a Tuesday, and then say, well, I'm gonna go back and refresh. I want to better my grade. And then on Friday, you could take it a second time. You don't have to take it back to back. You could take it and then take it another time. Or if you choose to, you can take it back to back if you wanted to. Okay. So, and that's how all the chapters is pretty much set up. You know, This one, like I say, you don't have two assignments. You know, you have one. You know, one assignment. All right. So now, if we go back, let's go to. I'm gonna open up Visual. Do I have Visual on this computer? Let's see. Hopefully, I have it. Yes, yes, yes. Yes. So what I'll do, I'll open up Visual Studio, right? Or do I have it? No, 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 no. Let me do something right quick. Let's put this here. Might have it on here. Hold up, MLM Wild Club. All right, let's see something. Let's see what we have here. Hopefully it's open up. Okay, let's see. I thought I had it on this computer. Nope, nope. All right. Okay. What I could do, I could show it to you in online GDB, but I wanted to show you a visual. And then on my other computer. Should have it here. Got to be here. Give me a second. Let's see something. Search for visual. Well, I don't have it on. I don't have it. No, it's taking too long. No, I don't have it. All right. So what I'm gonna do, I'm gonna open up online GDB. All right. So I open up online GDB. And when I open up online GDB, I need to make sure that I'm using what? C++. I can wipe all this out if I choose to. Now, the thing is, I can write my program. Class, I normally, when I'm face to face, I tell the students, create the shell in C++. What's the shell? I call the shell pound include IO string. So now that means you can input output. Then you got using namespace std. So now that loads the standard libraries. You can do the int main. All right, that's your main function. And then return 0 because you did the int main. All right, so now this is the shell. This is in a sense a program that has nothing in it. If I run it, I'll just get no output, but everything's working. And I would tell you to try to do this first, so you know you at least you have the structure somewhat set up right. All right. So see, it just gave me nothing. It just gave me a blank screen. See, the blank screen. Because if I go in here, cout is the command. If I do cout, and I'll just say double quote test. All right. I'll put a backslash in. I'll do backslash in backslash. Just two tabs. A return in two tabs. All right. And then inline and back in the backslash n is the same. So all they're gonna do is just gonna print out a new line, tab, test, and then 2 new lines. All right, so if I run this, all right, so I know my program structure is set up right. My logic is not there, but I have it set up right. But sometimes people may put curly braces here, and you know, you're running a program, you've written say 50 or 60 lines of code, and then you go to run the program, and now you're getting some kind of errors like, man, what's going on? Why? What's happening? I don't know what's going on. You know, so get the shell straight. And that's just my preference. You know, do your shell, and then you can start add in and out. And so CI is not wanting to run. All right, so I'm gonna just stop it. But you would get errors saying such and such. All right. All right. So, and I'll just run it now. Okay. I'm gonna try to stop this. Stop. I'll go. I needed to stop. Get out of it, leave it, and get back in it. All right. Now, so like I said again, make sure it's C++, and like I said, you can leave that using namespace, whatever. So that's what I basically just typed. The same information here, right? So you know that this is what you need. But then now what? Now you can start doing what you need. Now, what I'm gonna do is, yeah, I could leave hello world up. So this is a program that's running. I told you to create a header file and call the function from that header file into your program to be executed. All right. So now, what you would do is you can create your header file. All right. Well, you create a new file, and that header file need to have the extension .h. Okay. So I can call it whatever I want, and normally I just tell the students header.h. All right. So header.h. And now in this program, I can do the pound include. I will stream, because if I'm doing input output, I need that. Using namespace, all right, the standard library. And now I cannot, you gotta remember this, class. You cannot do int main, all right, or either void main in this header file. There should be only one main function, no matter how many associated programs you have with your project. There should be only one main function, and that main function should be in that .cpp program that you first execute. All right. So here, let's say we could call this head or my information, my info, or whatever you want to call it. Now, these parentheses just saying that we're not passing any arguments, all right? And then you got your curly braces. So now, within here, this is why you would do your cout, whatever, you know, if you're gonna do, and then you're gonna put name. I'll just do it like this. I forgot the format that I gave you to do. Do /t, and then I can say name. What, not name? Yeah. Program name. I can say prog1. Okay. And cout. And you're gonna have 3 or 4 output: the name of the program, my name, the due date, and the course. But I'll just put 2 cout statements in there. All right, so I'll do here /t. So if I put a /t, And then I'll say, no, I'm just add this, right? So I just added this just to show you what's gonna, and I can do another one. Now, so these are valid C++ commands, but it's just a function, all right? This function is gonna have to be called to be executed. The way we execute it is calling the head function. So now, we go back to our main program, okay? This is something that you're gonna have to question. Okay, I wanna load the contents of this header file into my program. How do I do that? Well, just like I did pound include IO stream to load the IO drivers to output my data, I want to load my predefined program header.h, so I would do the same here, right? But rather than use the less than or greater than symbols at the end, I have to use enclose it in double quotes and then .h, all right? So now, if everybody see this, because some people get this mixed up, what they'll do, they'll put header within a less than and a greater than symbol, like they calling a system header file. No, you have to put it in double quotes because it's a user-defined header file. You gotta remember that. Now, just doing this does not execute what? That function head, right? So what I need to do is I need to say, okay, I want to call that function. So what I do is I'll just simply call head, because what? The header file has been loaded. So now it knows that whatever's in the header file, I can use as if it was in my program. So now head. So what'll happen is, if I execute this program, it's gonna say, okay, load head.h, okay, use my standard library, and then, okay, open my main function, call head. What is head doing? Head says output program name, prog1, and go to a new line, and output CSCI 1943, summer 2022, all right? So it's gonna do that, and once it does that, then it's gonna output hello world. Mighty got it. So let's run it. So let's run it and see what happens. All right. Uh-oh, got an error. I got an error. Wait a minute. What did I do? It's right there. I think it's in here. Oh, so I use int head. Oh, that's why. I could use void, but if I use int, I have to do something like I have to return something. So if I use int, just like in the main, I have to return something. But normally, if it's nothing that you passing or whatever, you just let it be void. All right. So this should run. Oh, it didn't run. Expected a primary expression token. Where am I? Oh, that's right. That's right. That's right. Let me take this out. But that might be in the other program. And I'll take this out, make it void. Let's see. Oh, I gotta run the CPP file. That's the problem, Glad. You always run the CPP file, not the header file. Okay. And then it's still, wait, got an error. What the error? All right, what does it say? Okay, in void head, all right, in the function void head, expected error primary expression before the token of the double. Okay, before this. I got this. Oh, look here. What I did here, I ended the not the program. I ended the statement, and then I added another string. So that's what caused that error. All right. So let's go back. All right, and run the program. Run the program. Bam. So look. Okay, yeah. Programming name, all right, program name, prog1, CSCI 1943, summer 22, and then what? Hello world. All right. And like I said, the only thing I didn't have this aligned. This got 2 tabs, this got 1. All right, man. So that put a tab down. All right. And if I go back, I could put 2 tabs in the main function just to make sure, make all of them align alike, all right? But that's just cosmetics though, but the program is working. All right, so now when I run it, see, I have to get this off the screen. All right, see, this information is not in the main function. This information was called by calling the head function from header.h. Anybody with any questions as to how to do the header file? Questions? So you create your header file, but what? You have to load the header file. You have to call the header file. But in the header.h is where you define what that header file is, right? Or what it's going to be doing. Okay. Now, let's see. So that, and this is with online GDB. I don't have the visual. I wish I had the visuals, but you got the examples on how to open up a Visual Studio C++ file. All right. So now, that's that. Let's see what else. Questions. Where are they? Where am I? Okay, here. All right. So that's that was that on the header file. All right. Now, some people say they had issues with programs. All right. So we look at here. Okay. I can't do that. I'm not gonna do the program. If where's the bonus? All right. Looking at this, the bonus program. All right. All right, you have to have your header file. Okay. But what this says, what? You want to write a program that will declare and initialize 2 arrays. Now we did, and I think if you look in your notes, you got a program that's similar to this, to do this. All right, 2 arrays, all right? One of 10 elements, one of 5 elements. Using a function, output the contents of the first and second array. So what I'll do, I can do that, but that's bonus, like I said, it's done. So I'll do that, I'll show you. So if I go back to online GDB, go back to the online GDB. So we have our header file done, all right? So let's go back to our main function. So in here, we can create a variable, all right, or an array variable called int num1, all right? And let's say we make this 5, well, I'll do it like normally you would do it. So you can have something like const int, I'll say first equals 5, const int second equals 3. All right. So for our first array, we'll call it, we'll make it equal to what? 5. First is equal to 5. So what I did, I created an array that can hold 5 elements. And now I can initialize it, all right? And I could say equal 10, 20, 30. I got my other yeah. Well, it could be any numbers. All right. And 40. Done. And say 80. All right. So that's my 5 numbers, right? So that's the first array. And semicolon. Second one, int num2. And what? What's going on here? What's happening there? All right. All right, so here we go. 2, and I'll say second. Now, second is a constant of what? 3. So now I can declare an array of 3. So I could say 55, 88. What's going on? And 92. All right. So I have these 2 arrays. Now, the program says that I need to output the content of these 2 arrays by using a function. So I need to pass them to a function and then output that data. So I could create a function, right? When you create a function, there's 3 things you should do. Prototype, the function call, and the function definition. Prototype, what am I passing? So I'll say my function, I'll void, and I'll say array out. That's just my name, all right? And then I'm gonna pass an integer array, all right? And I'm gonna pass the size of the array, all right? So when I do my loop, all right, so that's my prototype. My function call, I'm gonna call my header file, which is my header instructions. Then I'm gonna call the first array to be printed. I'll call the function to print the first array. So I'll just do array out, all right? Now, I never defined it yet, but you'll see it. Then I could just do something like cout in line just to put a space here. I could have did it in the array. Then I mean in the function. Then I'll do another call. Well, I'm gonna add it array out again. But what's happening now is I need to pass parameters because in my prototype I said I'm gonna pass an array and a size. Well, an int array and an integer. So the first array I'm gonna print the first 5 numbers. So I need the first array, which is what? Num1. And what's the size of num1? First. It's 5, but I wanna make my program flexible where I won't have to keep changing. If I change it to 6, I gotta change the number 5 to 6. But if I change first equals 6, it's done throughout my program. All right. So now, same thing here. If I'm calling array out again, but I want to pass the second array, so now I'll pass num2 and then its size, which is second. Now, so I'm passing those 2 arrays, all right, to a function. So now, after my main function, outside of my body of my main, I want to define what my output function gonna be looking like, my array out function. So I'll do void array out. And where that's coming from? That's coming from my my definition here, my prototype. All right, void array out, void array out. Now I have to put my parameters. Now, at this point, you have to declare your array name, all right, and the integer that you want to use within that function array out. So I can use the same names here where I'm passing first, num1 and first. I could say int num1, all right, comma, int first. Now, the thing is, num1 in array out is different from num1 in the main function because it's 2 different scopes, right? Because I could have used a different a name. I could have just done in one, and then my curly brace, all right? Not my curly, my square bracket. Because what? It's an array, all right? So I have to tell it I'm an integer array, and it's going to be in1. So what's going to happen? The contents of num1 will be passed into n1. And then the first size, the first, which is equal to 5, I could pass it into FST. All right. So now in this function, right, my function has to have a body. A body begins with a curly brace, end with the curly brace. And now I need to tell it what I want it to do. Now here I could do a cout if I wanted to space down before I output my data. You know, like I said, it's just cosmetics. But then I could do a loop. I could say for, and then I could say int, and I'm introducing the value, x equals 0, all right? X less than what? What's our size of our array? Our array is what? First, but really we pass first into what? FST. So in this function, it would be less than FST, all right? And then what? We want to increment what? X. So X is going to go from 0 to FST, all right? So X plus plus. Now, once you do this, now you can just simply what? Cout, and I'll do a /t twice. And then I can output what? N1 sub X, because there's going to be sub 0, sub 1, sub 2, sub 3, and sub 4, then it kicks out. All right, this time. All right, then I'll do NL. Okay, and now we out. That's all we want to do. Print that and we get out. All right, so now it prints that, then it comes back here, and in here it's going to print an extra line. We could have did it within the program. Well, no, it's not. Is it here? Right. I did this backwards. This, yeah, that's right. This needs to be down here because it's not declared. They won't know what it is. I don't know why it moved it down. So I need to move this, because what? How can I use num1 when num1 is not even declared yet? I'll get errors. All right. So this needs to be after my declaration. Okay, so I'm gonna cut this and I'm gonna paste it down here. All right, paste it here. So now it's declared and now it understands it. So it's gonna print that. Then what? The second array is passing num2. And look, now we don't have to do any more work because what? The second time we call array out, it's gonna pass num2 array and its size. So num1, n1 gonna take on the contents of num2, all right? And FST gonna take on the value 3. So, and then here we're going from int x equals 0, x less than FST, which this time it'll be 3, and it's gonna output it. All right. So let's run this program and see what kind of output we get. Hopefully I got all the errors out. All right. Now, the only thing is I should have, well, not say should have, if I was representing the data like I did in the assignment, I should have just done a /t. Oh no, I could just do a comma. Oh no, not a comma, space. All right. All right, because there's no inline, right? So now, so it's gonna do that, and then what I'll do is see how inline outside of the loop. Now, so let's run it now, all right? So here, oh, I spaced through. Oh, I see why. Every time I'm doing a double tab, that's my problem. All right, so let's run it. Yeah. I'm trying to make it close to what I have because I don't want you to, right. All right, so look here. Let me scroll this up. So you see how you have the first the contents of the first array, 10, 20, 390, 40, 80, right? The program was called and it outputted the information, went back. What the function was called here, it printed what? 55, 88, 92, right? Yeah, so now, and the thing is, I could have done them in reverse, all right? If I just simply take this information here, all right, and moved it above this one, the only thing we're doing now is calling the smaller array first and printing it, and then and call it, or passing a smaller array and printing it, then passing a second array and printing it. You understand? So it's like once you start creating functions, you're able to manipulate. See what happened? So you're able to manipulate your arrays in a whole, your document or your data in your program in a much better and organized way. All right. So now I was talking, but that was the bonus program. Now, anybody with questions? I may not have went over what you wanted or needed answer to, but questions. Anybody question? Hello?
Does first equal FST? Nah.
It depends. Well, let me ask you that. Well, how are you asking the question? Ask it again. It's first what?
Does first equal FST?
We never assigned first to equal to FST. First is equal to what?
That is number one.
First is equal to what? Let me scroll up. First is equal to what?
Oh, 5.
Understand? Now, that 5 is the size declarator of your array. You understand? So when we're looking at this saying int num1 with an array size of 5. And then what? We made first what? Constant. So that means first cannot change throughout this program. You cannot change that value. If you do, you violating the programming code, and you're gonna give you an error. That's gonna be a violation. Now, FST on the other hand, when we call, let me scroll on. And remember I reversed these two, right? I call num 2 and num 1. I call num 2 first, right? So if we look at this, we called array out. Array out says send num 2, all right, and second to this portion of this array, this portion of the program. So what? Num 1 gonna equal to what? 5, 85, 88, and 92. FST now gonna equal to what?
What? 10, 20, 390, 48?
No. FST is the size declarator we passing for the array we using. We passing second. Num 2. Num 2 size declarator is what?
For 3?
Right. So what's happening is, you see second is equal to 3, num 2 second, so that's 3 here. Then so when we pass second, we really passing the number what? 3, correct?
Yeah.
So when we pass the number 3, it's gonna be stored in what? FST, and now we can use it in this portion of our program, this function, as FST, which is gonna be what? 3, right?
All right.
So what's happening? X is 0, 0 is less than 3, yes. X is 1, 1 less than 3, yes. X is 2, 2 less than 3, yes. X is 4, 4 less than 3, no, kick out. You got it? And then so when it calls the second array, when it calls num 1, it's gonna call array out the second time. We pass a num 1 to n1, and then we pass it first to FST. So now FST is equal to what?
5.
5. There you go. That's what's happening. Right. So we passing that every time we passing that value into that particular variable. Correct. There you go.
All right.
That's what's happening. Yeah. Yeah. Any other questions? But this program shows how we can use one array to do multiple things. You understand? Well, call it more than one time. But because we passed the size and we passed the array itself. Right. Anybody else with any questions? Questions? Miss Jupiter?
No,
Hello?
sir, I don't have any questions.
Oh, okay. So you kind of straighten up?
Yes, sir.
Okay. Hopefully I answered the question. I know I went on and kept talking and as into the program and whatever, but hopefully I answered some of the questions. Once we finish though, I'm gonna post this so you'll be able to look at it again. You know what I'm saying? Review it. I also, like I said, went over the header file. So hopefully you'll be able to do the header file, and do that without errors. All right. Yeah. So any other questions? Anybody? Hello. Now this is 194. Now those programs, I won't say they real hard, but they're a little tough. They're a little tough. And any little slip up or misunderstanding, man, it could give you headaches. All right, it could give you headaches. Now, as I say, you always can reach out to me. And if you ask any one of my students, I will not give you the answer, but I'll direct you to where you should be looking at, with the issue that you have. All right. Give you an example. If somebody was writing this program and say, for instance, they had something like this. What? That's something like this. All right. So when I run this program, I know for a fact I'm gonna get an error. And who could tell me why I'm gonna get an error in this program? I just added 2 more values into this array. But what's the size of this array? What it should be? How many elements?
3,
And I made it what?
5.
5. So I'm gonna get an error. So a student might run this program and they'll get errors. You understand what I'm saying? And they'll be like, Mr. Vessel, I don't know what's going on, whatever. And sometimes I could look at it and kind of pinpoint whatever. But then if you give me your error message, and that's one good thing a good programmer can do. They can look at an error message and kind of decipher somewhere what the problem is, because you're gonna have to be able to do that. You cannot write code and it's like, oh, I got this error, but I don't know what it is, and I can't figure it. No, you got to be able to analyze it. Because looking at this, it say what? At this line, int num2 second, okay, and we got what? 50, 55, 88, 92, 3, and 92. All right, so it says too many initializers for int3. So we said, well, int3. If it's int3, then what? The maximum for this should be 3. You understand? So you got to kind of analyze those error messages so that you'll know what's going on. And it's not the first one, because what? It says for what? Int num2 second, right? Not in, because some people say, okay, well, let me change this. This should be just 3, and this one should be this 3. So, but if I do that, if I say, okay, I see my error, this should be 3, and where's that? Right here, and this should be 3. What's going to happen here? Anybody? Can anybody tell me what's going to happen here?
You won't get an error at first, right?
I'm going to get an error again. Why?
You only have 3 arrays?
Correct. I specified to be what? Well, I won't get an error. I won't get the error here. Yes, I will. No, I won't get the error here. You know why I'll get the error? This is why I'll get the error. I'll get the error here. Because when I pass first, which is 5, right? To this, this gonna wanna do it how many times? 5 times, correct?
Yes.
So I can have a large number here and specify a small limit, but when I process it, I cannot process to the end because I don't have nothing else. You got me? So when I run this, oh, well, it give me 0, but really, you know, that this is online GDB. Remember, I told you there's a difference in the two applications. The Visual Studio would have gave me an error. Online GDB kind of like do the default. Hey, if something is not initialized, I'll just make it 0. But in the more advanced compilers, you'll get errors. All right, you would get errors. Okay. Any other question? Anybody else?
When submitting code assignments, is there like a way to get partial credit, or if we don't have it exactly right, it'll be a 0?
Well, yeah, I'll give you what I'll do sometimes. Not how would I do it? How would I say it? Man, if you got errors in it, I normally give a 0. No, I would tell students you should always try to get out all of the errors. You know what I'm saying? Now I can understand if you got logical issues like, oh, this is not doing whatever, or the numbers are not right, whatever, and you couldn't figure it out. Okay, but to get the syntax errors where the program just didn't run, that's when I say, they didn't really work that hard on it. You know, you worked on it, but it's like, oh, well, whatever, that error. No, I want you to diligently work on it. Try to get those errors out. Try to work on debugging your program, understanding how, why, but just like what we did here with the array. You know, like some people get that, oh, well, I'm gonna just turn it in like this. I done wrote all this, I'm gonna turn it in. But you got errors and you want the partial. I want you to grind. I want you to work at it, getting them errors out. And then let's figure out that logical part. All right. But now, this is the thing. You brought up that. What I'll do is, but I wanted to see how many people would log in, but I guess y'all have the advantage. But they'll probably see it. What I'll do is for the modules, when you do have time to do the other one. Because y'all still have time to do, and that's what I did. I said for the first program, I would give them extra time because you have what? Till, what's that, web program 1? Yeah, you have until the 8th, I think, which is what, tomorrow, right? To complete those 2, correct? But how many people turned in the bonus? Because what I can do, I can extend the date for the bonus till the 8th. And I'll give you that little extra time to try to get, well, oh no, these, this one. So you can get that one also. All right. So let's say something. What's going on? All right, so like I said, I'll just make this which is tomorrow. All right, June 11th, that should be the 8th. June 8th. That was the wrong date on that. All right, so yeah, so that's I'll let that, really I had it too long, but the 8th. So give you time to do that one. All right, so now how everybody coming along with the other program, the other 2 programs? Program 1 and program 2. Because that program 2 deal with vectors, well, not functions, but vectors and arrays, they work similarly, but there are some differences.
I started on the first one, but my numbers weren't printing out correctly, so I'm working on adding the text file.
All right, so that's this one here, right? Program 1. That's this one, right?
Yes, sir.
All right. So now let me ask you this. Or this is what I tell my students a lot of times. You may want to, you don't have to, you may want to work on your program in sections, right? Where you work on and say, well, okay, he want me to read in the data. All right. So what I'll do, I'll read it and print it out and see if that works. See if I'm getting the right data in, read in the right way. And then what happens if you're reading it right and printing out right, then you take that print out of that function, and now you go to the next function. And you know it's reading, and now you go to the next function. Now you make it do whatever for that next function. All right. And then you need to calculate. Do your calculate. And now you need the output. Now you do your output. So, but I'm saying you can do it that way. You don't have to. But in this program, this program is a program where you're going to have one string array of names, right? But you're going to have two-dimensional arrays, one of scores. No, not two. No, one two-dimensional array of scores from which is 0 to 4, which is 5 scores for each student. And then you're going to have an average. Now, I don't know if any of you was confused with this program. You're not supposed to do both two programs for this program one. You only do one program depending on what your last number is in your ID. If the last number in your ID is odd, 1, 2, 3, 4, 5, 6, 1, 2, 1, 3, 5, 7, 9, you will do the top portion. You will do this part. If your number ends in an even number, you will do the class average portion. Period. You're not doing both of them. All right. So a person with an even number, they're gonna do an odd number, their output gonna look like this. Student name, student scores, that student average. Name, student name, score average. All 15. But a student with an ID number ending with an even number, their output gonna look like this. Student name, test score, student name, test score, student name, test score, all 15, but then at the bottom, the average of score 1. So that's like a class average of the students who took the test. The average of score 2, the average of score 3, the average of score 4, and the average of score 5. Everybody got that? Now, I'll give you a little hint. The trick to it is the person that have to do this one is straightforward. The person that has to do this one have to reverse their inner loop and make it an outer loop when they're doing their calculations. And so that's how that works. All right. So you're gonna have an array for student ID, and it's gonna be a string array. So your data file gonna have a name, one name, just no spaces, just one name. Then it's gonna have 1, 2, 3, 4, 5 scores. Name, 1, 2, 3, 4, 5 scores. Name, 1, 2, 3, 4, 5 scores. 15 different ones. That's your input file. You're gonna read in that data, read in the name, read in the scores. Now, when you read in the scores, you're gonna have to read in that two-dimensional array. You're gonna read scores sub 0, 0, scores sub 0, 1, scores sub 0, 2, scores sub 0, 3, scores sub 0, 4, scores of 1, 0, scores of 1, 1, scores of 1, 2, scores. So what happened is you're reading in the row, column, row, column, row, column, row, column. Then go to the next one, row, column, row, column, row, column, row, column. Go to the next one, row, column. So you stay stuck on the row until you read everything in the column going across. Read the next one, stay on that row, read everything in the column. Stay on the next one, read everything in the column. Then Now, some students say, well, Mr. Vester, I could do the average once I read it in there. No, I want you to create a function that will then take the array, manipulate the data by going through a loop, the two-dimensional loop for two-dimensional data for the scores, and then calculating a score for an average and putting it in an array where the first one is sub 0, next one is array average sub 1, next one average sub 2, on and on and on. All right, and then you're going to output the name going to be outputted in a loop outside of the inner loop, because the inner loop is going to be the second or the column loop where you're going to manipulate outputting the scores. So then you're going to have the scores outputted, and then if it's odd, you're going to output that average. Then you go back, print out the student again, on and on. But if it's the other way around, you're gonna all of y'all gonna have the same way of output, but processing the average gonna be the part that everybody gonna have different. And then the way the output, because one got to output the average student score than the average test score. All right. And then your data file should be named data underscore and then your first and last initial .txt. All right. I think, well, no, I thought I may have had something if you go to announcements. I got my other class in a little while. Did I have anything in here? No, I do it right. No, but you're gonna have to have a two-dimensional array to do your scores. All right. You will have to have that. Okay, any other questions? And this second one, how about this? The second array, second one is header file. Oh yeah, this one dealing with vectors and the cost. Right. All right, any questions? Any other questions? Hello? Tell you what, if I could give y'all an extra day on this. But I want my work though. But y'all got me up like fall a little behind. Let's see. Yeah, I'll do that. All right. Okay. Yeah, so what I'll do, I'll give y'all an extra day on this. And like I said, hopefully you turn my programs in. All right.
Okay.
Any questions?
Right now, if I came and waited.
I can't hear you.
No, ma'am, I do not.
Oh, she done.
Okay. All right. Thank
You're welcome. Have a great day.
Yeah.
Hello.
Yeah. All right. So like I said, I'll change the date. Because I got my other class on the Zoom too. All right. Y'all don't get my work done, right? Hello, Clem.
Could you repeat what you said? I'm
I
sorry.
say just go ahead and get my work done. All right. I'm gonna move
All
the date.
right.
Yeah, I'm gonna move the date back one day, and I'll give y'all a little extra time to get this done. All right.
All right. Thank you.
All right, no problem. All right. I need to open up the Zoom for my other client. All right, so I'll see y'all up. Well, I don't know if I see it again, depending. Yeah, depending if I make another Zoom session. Yeah, I'll see y'all next time. All right, have a good one.
Thank you.
You're welcome.
You too.
All right.